To physics and mathematics lovers, once again, before us here is a question on limit. Mind you, we are still dealing with a limit of what? Functions, precisely trigonometric function. So here we have a limiting function of as s tends to 0 of 1 minus cos mx all over 1 minus cos nx. So this question looks somehow, but let me tell you one thing. Remember, in our trigonometry we have identity for only sine of what? X, or sine function. So like this now, if I should plug in the value of s here to be what? 0. Let's try and see what we are going to have. So it means that anywhere you see s, you put your what? 0, which means here will become what? 1 minus cos, then we have what? M times 0 all over 1 minus cos n times what? 0, which will now give me equal to 1 minus cos 0, that is what? Cos 0 all over 1 minus what? Cos 0. So in our trigonometry, cos 0 is 1. So which means here we now have 1 minus 1 all over 1 minus what? 1 equal to what? 0. No. So this is an indeterminate what? Value. So we don't accept this. It's what? Undefined. So that means there has to be a way we can what? Do this. So we have different ways, but let me use the simplest one, which is a clearer view. So what you need to do now, according to hospitals, you need to, you are going to differentiate with respect here, differentiate up, differentiate what? Down. Which means I am going to have what? My limit function now as s tends to 0. I am going to differentiate this one with respect to what? X of 1 minus cos mx, then all over the differential coefficient of this, also the s of the denominator, 1 minus cos nx. So doing this, we are going to arrive at a very good answer. Now look at it now. It means for this differential we will differentiate 1. If you differentiate 1, it's a constant, that will give you a 0. So which means here we don't have what? Our limit x tends to 0. So if I differentiate with respect to 1, it will give me what? 0 minus. Now differentiate this one now. That means I'm going to have the differential coefficient of what? This cos mx. Then all over this one now. The same way here, if I differentiate the constant 1 here to give me 0 minus, then we need to have the differential coefficient of what? Cos nx. So now, if you look at this cos ms here, there is a function there again, which is what? M. M is now, with that means we're now having a function of a function inside there. So we're now having what? A composite function, which means I am going to differentiate for just cosine, which is cos of what? X. Remember, if you differentiate cos s in our trigonometric differentiation, it's going to give you what? Minus sine s. So when you differentiate this one of cos s, it will give you what? Minus what? Sine s. So now we see have another function now. We say, well, let anything be equal to this ms, which means we are going to differentiate mx. So when differentiating ms with respect to x, so we are going to have our m. So what am I trying to say? Which means I don't want to go too far. So knowing all these things, we are going to plug in all this. So function of a function now, we then have what is called, we have the u, that is the y, the s. The y, the s will now give equal to what? The u, the s times what? The y, the u. So at the end of the day, this one can cancel out. So which means we are going to plug in the whole of this one in what? The numerator and what? Denominator. So that, let's go. So here we have what? Limit function as s tends to 0. So we then have what? This one is 0, is gone. So we then have a minus here. This minus is already here. Then we are going to have a minus here, which is minus here. Then differentiating with respect to this now, we have what? Minus what? Sine ms. ms, then times, remember we are going to differentiate ms again, which is what? M, to give what? M. Then all over, the same thing that happens here, we also differentiated. This 0 is gone. We have a minus here also. We have a, yeah, we have a minus sign ns, nx, then times n. So that is what happens there. So the next thing now, we can open your brackets now. Open brackets now. So which will now have a limit function s tends to 0 of this one. We have a minus sign. This one will give us what? Plus. Now give equal to sine ms. Okay, let's bring this one. Let's bring this one. This one will multiply here. This minus sign will become what? M times what? Sine mx all over what? This one minus times minus is what? Plus. Then this n will come here, become what? N times what? Sine nx. So we look at it now. Something is still wrong here. So we have differentiated now. So after differentiating, we still have a sine function. And when you plug in 0 for sine function, we are still going to have a determinate value. So which is why we need to go further again. So you need to go further to differentiate second time. Okay, so let's screen here. So at this point now, if I carry out the direct substitution here, which is this 0 here. So after differentiating once, this is the first derivative now. So if I put my 0 here, I'm still going to have an indeterminate 0. The whole thing will still give us what? 0 over 0. So which means I can still go further again to differentiate now. So let us differentiate now. We just take this one m. This one is a constant now. So this one is already outside now. So it is this one that is our interest now. We leave this m. Okay. So we differentiate with respect to this again. Well, we don't have what? Your limit function of s tends to 0 of this one. We have to differentiate again. We have the y, the s of we have m sine mx. Then the same thing, also differentiate with respect to this one. We have the s of what? N sine nx. So it's now at this point, so we have to differentiate what? M sine mx. Then all over what? This also differentiate this one, n sine what? Nx. So this one is a constant here. Let's bring it out. So we have what? Limit now. S tends to what? 0. Then we can have what? Your m times what? The derivative of what? Sine mx. This one. Then all over, bring out all your n. N times what? Derivative of what? Sine nx. So now let's go. Sine ms is another function of a function inside there. So that means we will differentiate in respect to what? Sine function of the angle. Then we also differentiate in respect to what? This mx. So if I differentiate mx with respect to x, it's going to give me what? M. Which means here I am going to have my limit s tends to 0. So here m is already outside. We have what? M is already times derivative of this one, sine x. It will give me what? Cos. Cos. It will not give me cos ms. Then when you differentiate inside, which is another function inside, it will give us what? M. Then all over. Let's go to this one also. Your n is already here times. Then differentiate sine function now. It will give me what? Cos nx. Then differentiating with respect to what is inside again, which is this function nx. So it will now give me what? N. Differentiating with respect to x, it will give me what? N. So at the end of the day, we are going to take a limit now. Then become limit of this, bring it down, s tends to 0. Then m times m to give us what? M squared. Then we have a cos times what? Cos ms all over n times n to give you what? N squared times what? Cos nx. So here we can go further now to carry out or direct or substitution. Yes, carry out or direct or substitution, because no limit identity for cos function. So at the end of the day, we're going to have a plug in 0 wherever you see x. So you're going to have what m squared times cos m times 0, then all over n squared times cos n times 0. So of course, m squared times cos 0 all over what n squared times cos 0. So in our trigonometric, cos 0 is 1. So which means the whole of this place become 1. We have what m squared times 1 all over what n squared times 1. So our final answer becomes what m squared all over what n squared. So this is the limiting value of what this question. So if you find this class very interesting, please do not hesitate to share this video to extend this knowledge to people who need it. And also do not forget to subscribe to my YouTube channel, Physics and Mathematics Lovers. Bye.